Hi guys, I'm working on a larger project where I need a lot of inputs. The Texas Instruments TCAL9539 is a perfect match for my project. It's an I2C to 16-bit port expander and it has an agile GPIO interface, which I find very useful. The input pins on this expander can be set as latching, which I need. To test the port expander, I will develop a small breakout board in KiCad, similar to the ones you can get from Sparkfun and Adafruit. In this video I will go through the whole process from making the schematic to routing and ordering the PCB. The features for this board is that we have pins for all 16 GPIO signals plus ground and 3.3 volts. We have pins for SDA Sccl, interrupt, reset, A1 and A0. Then we have 2 quick connectors and we have 4 3.2mm mounting holes. We have a power LED on the 3.3 volt rail. We have an I2C address select option via A1 and A0, and we have I2C pull-up resistors that can be enabled and disabled. And the last two things will happen via some solder jumpers on the backside of the board. So just before we start the project, I would like to thank PCBWay for making this video possible. Remember that there are a large section on PCBWay.com where you can find a lot of projects and inspiration from other makers. If you find a particular project interesting, then you can often directly order the PCB at PCBWay. You can find my affiliate link in the video description of this video. Please use it and thereby support the channel. So remember to visit PCBWay.com. So let's dig into it. Okay then, let's get started. We will make a new project. And I already created a directory here, KiCad and YouTube, and I have some libraries here for 3D drawings, a footprint and different symbols. So I'll just make a new name here for the project. I'll call it Instruments TCAL9539PWR. And we will not update right now. So we have here the schematic and the PCB, and we can open the schematic. We have a template here, and we can just add some settings here. So we have the size. I hope I can have it on an A5 page. Let's see if we need to increase that a bit later. We will insert the date, version number, version 1.00, title, and we will call that made by Morten. And I think this is good for now. And we can see this has already been inserted here. Perfect. So the main star of this project is of course the TCAL9539PWR, and I don't have that as a part, so I think we'll start designing that one in the library editor or the simple editor over here. So we will make a new library here, and it's a global one, and we'll place it in here in my library KiCad, YouTube and KiCad symbol, and I will just rename this as YouTube library KiCad. Let's do it like this, like that. And then we can create a new part, new symbol here, and we will call that TCAL9539PWR. New one, perfect. Great. And we can start making a body. That. And we would like to fill it like that. So this looks very much like the standard. And then we need, of course, to add some pins. And I have the datasheet over here from the Texas Instruments webpage. So we have the TCAL9539, low voltage 16-bit I2C bus, IO expander with interrupt output reset and configuration registers. And I will select this TSUB24 package. And here we have a block diagram of it. And down here we have the pinout. So I basically have to take these pins and transfer them into our part. So the IO pins, they are on pin 4. They start on pin 4, and then 8 of them go down to pin 11. So that's P0. And over here we have P10 to P17. So I can put them on the right side of the part. So we will place a pin, and that was P0, and the pin number was pin number 4, and it's a bidirectional pin, and we need to change the orientation. Sorry, like that. It has to be right. And I need to change this. It has to be left, of course, like that. And then I just need to add more pins. Copy, paste. And then we have pin P1, pin number 5, P2 on pin number 6, and P3, pin 7, P4 on 8, P5 on 9, P6 10, and 11, that's P7, like that. Then we have the first 8 GPIO pins here. Just take and move everything up here, approximately like that. Then we can increase the size of the body here, the package, and we can try and copy this. Like that. And then it will start here. What was it? So we have P10 on pin 13. And it's already on pin 13 here. And we need to rename it like that. And then we have P11 on pin number 14, P12 on 15, P13 on 16, yeah, and P14, 17, P15 on 18, and P16 on pin 19, and finally P17 on pin 20. So we can just verify that with the datasheet. And the last one is P17 on pin 20, so that's correct. And then we can add the power pin, that's VCC on pin 24. And yeah, we could make it a bit wider, maybe the body here. Like that. And like that. And then we will add a power pin, and that's VCC, and that was pin 24, and it's a power input and right side. Like that. Then we have the SDA and Sccl pins, and SDA on 23 and Sccl on 22. Place pin and SDA, and that was on 23, and that's a bidirectional pin. That, and we can just duplicate that one. And then we have the Sccl pin on pin 22, like that, and a reset pin. Need to find it here. Reset on pin number 3. And you see in the datasheet this is active low, so we can place the tilde and the curly brackets, and then the name, reset, and then close the brackets, and then we have a negated pin here. And it's of course an input pin, like that. And I believe we have an interrupt pin as well. Interrupt is on pin number 1. And we also have the tilde and the curly brackets, and we call it int, and close it like that. And I forgot to put the pin number on, so that was pin number 1, and I believe that reset was pin number 3. Then we have the address pins. So where do we have those? We have A0 on 21 and A1 on pin 2. So we will place 2 input pins. So that's A0 on 21. And duplicate that one. And that was pin number 2. And that was A1. And finally we have the ground pin. And ground, where do we have it? That's pin number 12. I can just take this one up here, duplicate it, and just rename it. And that was pin number 12. And it was ground. Like that. And maybe I should move those up a bit. Like that. And then we have the reset and interrupt pins. I think this would be okay. Something like that. So here we have the part. Let's save it. And we can see if there are some properties we can already insert. So we have the value here. That's TCAL 9539 PWR. And the footprint, we can already select that. So let's check up on the footprint in the datasheet while the libraries are loading. So that's a 24-pin TS sub. And let's have a look down here. Normally we have the dimensions down here. So what's important is the pins, or the distance between pins is 0.65 millimeters. And what body size do we have? So that's like 6.4 times 7.8 millimeters. Let's see if we can find that one. So let's go down here and see in packages. So that would be in like SO. And let's have a look on TAS sub packages. And it's a 24-pin. And this is the 1.65 millimeters, or this one here. This is too wide. So this is 4.4 millimeters times 7.8. Let's check with the datasheet once more. The body size was 4.4 millimeters, yeah. So this is the one. And let's press OK. And the datasheet, we can also insert the link to the datasheet. So we can just take this link up here and copy it in. And the description, let's say 16-bit I/O expander. Like that. And we can see this has not been saved, so this will disappear as soon as we press save up here. Like that. And we can just take all these extra informations and put down here. Like that. And also this one. That will be the name of the chip. I normally put it down here. And we have some other informations. And I place it normally over here on the left side. Alright, I think we got the chip. There's something here with the distance is not correct. I need to pull this up a bit. Like that, I think. And we got to move these up a bit as well. Like that. And like that. Yep. Perfect. Let's save this and head over to the schematics again. And then let's place the part. And we have now the library called YouTube down here. And there we have the part. Like that. And I don't know why it has moved the part number, but let's put it down here. And the designator over here. And we can then put some wires on. And we can use the pin helper function on this part. So place or add wire, and then we can right click here. Wire. Oh, sorry, we have to double click here on the pin here and right click. We can make a wire out here, or we should highlight all the pins that we're interested in, and then right click, and then we can put wires on. Like that. And then we can also take the labels and put them on. Just need to select all of them here. And then right click again, pin helpers, and then net labels. And then move, and then we can just insert them. So that's very easy. And we can do the same on the left side. And then just put some wires on. I think these ones need to be a bit longer because we need some pull-up resistors and some extra stuff. So let's move them out approximately here. And we can also put the names on here. Yeah, and the ground we don't need, and the VCC pin we don't need. And highlight, right click, pin helpers, net labels, and move. Like that. Just move them a bit here, the labels. Like that. That's quite easy to put the labels on like this. And we need to put the power on and the ground. So we will place a power symbol. And we need one 3.3 volts. That, and a wire. that, and then a ground symbol. And we have a ground symbol here, like that. And we can just move this up a bit here. And let's insert a wire, like that. Alright, so we need, on the breakout board, we need to have all the 16 bits out. So I will place two 10 pins connectors and then have ground in the bottom and VCC in the top. So we will just find a symbol and a pin header. And we'll find that under connectors, generic. And that's called 1x10. And we will just call that one pin. One by 10. Like that. And we can move this down here. Designate up there. And we need, of course, two of them. Like that. And then we need 3.3 volts on the top. We can take this one. And we need to insert it here as well. Maybe we need to make it a bit smaller. Like that. Yep. And then the ground symbol. Something like that. And then we can just copy the labels here. Like that. And the remaining 8 bits. Like that. Okay, then we have the GPIO pins sorted, and then let's see what we should do here. So I would like to have the SDA and Sccl pins pull-up resistor on those, and I would like them to be so that we can disable them on the board. And I would like to have an pull-up resistor here on the interrupt pin, and of course also here on the reset pin. And for the address pins, I would like to have some solar pads or solar jumpers, so I can select if the A0 or A1 should be high or low. So let's try and insert some resistors here, and I think like 4K7 or something would be a good value. So add symbol, and I can just search here R small, could be an OK one, and 4K7, and I would like to have that a bit closer here. Like that. And I need 2 of those for the interrupt and reset. And I would like just a power pin connected to that. Duplicate, Control D. And then wire. And this one should go to the reset pin. And this one would go to the interrupt pin. So now we have the SDA and SCL lines. I would also like 4K7 resistors on those. Duplicate. And let's place them around here. Maybe this should be a bit further out. Like that. And this one would go to the SDA line. And this one would go to the SCL line. And let's see if we can find some solar jumpers. So they should be around jumpers. I need to remove that one. So let's see, jumper. Yeah, I think that could be one. And it's the one that are open. I think I'll try that one. And we can just remove the text here. Let's remove that one and call these ones SJ solder jumper 1. And if I rotate it like that, then we need to move the resistors a bit. Put some wires on here. And the power. Something like that. And I would like them just to have the same height. I think that it looks a bit better. Are they on the same level? Yep. And then we can move the designator up here. Like that. And then it's possible to enable and disable the 4K7 resistors here on the SDA and SCL line. And that's if you have, from your computer board, if you already have pull-up resistors there, then it's possible to enable and disable them here on the board. So that's basically it. I think I need some decoupling capacitors on the port expander itself. So we can try and find the symbol for capacitors. C, and then small here. And I think I will add a 100 nano or like a 10 micro. And I will add a 100 nano. And we will put power. And some ground. Like that. Some wires to connect it all. Yeah. And we can just put some text here so that we know what SJ1 is. Place text. So we can just write SJ1 enable disables for K7 pull up resistors on the SDA/Sccl lines. And then we can say default open. Yeah, something like this. And then we will have it aligned to the left. Perfect. So the other important things is of course the QWIIC connectors that brings the SDA and SCL or I2C lines to the board, and also the power and ground. So I think we should design 2 of these connectors, and I will just show you. You can see all the specifications of the QWIIC connector on the Sparkfun Electronics their homepage. There's a lot of informations. You can also find symbols for the different CAD programs. This is what we're interested in, the pinout here, and also the type of the connector. So yeah, if you're interested, then please go and visit the Spark Home webpage here. I'll also put a link to this page in the description. So let's put on a couple of connectors, 4-pin connectors. And we just need to find connector. Remove the C here. And in the connector we need 1x4. It's a generic, like this. And I would like it to be rotated like that. And I will rename this to a QWIIC right angle like that. And description down there, designator up here. And let's put some names on. Let's put a wire here. So the upper pin here should be, I believe it's SCL. Let's check it out here. So we have the SCL line, SDA 3.3 volts and ground. L for label. So we have the SCL line. Then we have the SDA line. And then we have 3.3 volts, and then we have ground. Something like that. And then a ground symbol. And a wire. Like that. And we need one input and one output. Then we can put extra boards on. So let's just duplicate this one. Like that. And let's put just some text on here so that we know a bit about the colors of the cable. Add text. So we have the QWIIC connector pinout. Like that. And we could just edit this one, put some more text on here. So we have pin 1, that's ground, and that's black. We have pin number 2, that's 3.3 volts, and that's red. Then we have pin number 3, and that's SDA, and that's the blue color. Sorry. And we need to align it to the left. I need to pin number 4 on SCL, and that's yellow. Like that. And there's a bit of information about the QWIIC connector here in the schematic. And what else do we need? We need to find out how to design the I2C address select function. So we have the A1 and A0, or A0 and A1 here, and we want to be able to select those pins to be either high and low. That's the way we can select different addresses here. And one way to do it is to pull them down by default and then have a solder jumper that if you put a solder blob on top of that, then you short circuit it and then it'll be 3.3 volts. So let's try and design that. So we need a source of 3.3 volts, and then we need some solder jumpers again, but only a 2-pole. So we can just try to find the jumper. and it should just be 2, and if it's open, that would be perfect. So let's place 2 of those. Just remove the text here, rotate it like that. And this is an solar jumper 2. And one more is needed. So we will connect those 2 to 3.3 volts. Like that. And then we'll need some pull down resistors. We could also use 4K7 for that. And let's put them down here. A wire. And then we need some ground. Like that. And then we can take and put a 0 in here. Sorry. Duplicate this on the other side. And then we need that to be a 0. And this one should be a1. Then we have the selector here. We could also add a bit of text to explain a bit about solar jumper 2 and 3. So place some text. So we have solar jumper 2 and solar jumper 3. Set the I2C address like that. I need some more text here. Of the TCAL9539PWR. Like that, and we also need to align it to the left like that. And then we could also write a bit of text regarding which addresses these will indicate. So if we have both low, which address will it be, and if A1 is high and A1 is low, which address would that then be? So we can place a text again, text, T for text. Let me write I2C address SnapEDA like that. And then we can say A1 and then A0 like that. And then we just need to investigate in the datasheet which addresses that would be. So we could try and find something about the registers. Normally this is the beginning of the description of the registers. So we have a address reference here. So if both of them are low, then it's address number 74 hexadecimal. So let's write that. Sorry, I need to go into here, the schematic. And then we say, okay, if both of them are low, that is equal to 0x74, and we will see if they are open as default, then they will be low, so that's also our default. And then we have 01 address 0x75 10 0x76, and if both are high, then we have address 77, something like this. Perfect. Then there's a bit of description also in the schematic. It could also be nice to have a LED that indicates that there's power on the board. And I would also like to have, you know, the signals here on a pin header that are separately available on the board. So I will also need a pin header for that, but let's find an LED. We can just take a resistor, place, and I think we need like a 1K resistor. We need to give it some power. And let's find a LED. Let's see, LED. Let's see if there's just an LED symbol somewhere. There's one there. And I would like that to be a green LED. Like that. And then of course we need ground. Like that. And then we have the remaining symbols or labels over here that we want to have on a pin header for itself. Let's see if we can just cover those. Down there. And then we have 6. Then 2 by 3. So let's find one on the connector. And generic connector. Two by 3, odd even. This could be this one, and we just call it pin 2 by 3. This is just standard pin headers. Put some wires on. Like that. And over here we want the SDA and Sccl lines. Maybe the interrupt over here. Reset. And then A0 and A1. Perfect. Then I would also like to have some mounting holes here. Let's just try and find some mounting holes. And I think they are in a library called mounting. Mechanical maybe. Mounting hole, yeah. And we just need some simple ones here. And we can remove that one. Like that. And we need 4 of them. Like that. And let's see if it should be possible to divide the things here by a dashed line. Line here. And I would like to have a dashed one. Something like that. What types do we have? Dashed. Like that. And then we can place one here. Place. Add lines. So that's L for lines. And one down here. So now we have divided the main things here. We could also add a small header on top, or a description for each box. So text. So we can call this one QWIIC connectors plus mounting. We can make that 75. Something in like this. Maybe we should move this a bit down. Like that. And what do we have here? That's I2C address select. It's 75 as well. try to center everything a bit. Something like that. And we can move this down a bit here. And place a text LED plus header. Like that. And then finally over here, we can just call it the name of the chip. Copy. And then text. Paste. Something like that. Are they on the same line? Needs to go up a bit. Like that. So now we have a complete schematic here. What could be nice was to annotate this. Then we have the possibility to do that. So we can do annotate schematic, an entire schematic, and reset existing ones. I think that's perfect. Let's try and see what the names will be. So we have, I would like those to be J1 and J2, these ones, because that's main connectors. So this is J1 and J2. We need to move this or this one down a bit. Like that. So this is J2, 1 and 2, and then we have J3 and 4 over here. Then I think it makes a bit more sense. And this is U1, solder jumper 1, and solder jumper 2 and 3, and J5. I think that looks fine. So now we have annotated everything. Let's just save what we have so far. So in order to start the PCB layout, we need to define the footprints for all the components that we have here in the schematic. So we can do that quite easily by saying tools and then edit symbol fields. Then we have a complete list here of all the parts, and then we can just fill in the footprint here. So let's start from an end. So the 10 micro capacitors, I would like that to be like a, just make it a bit smaller here, a 0603 package. So let's look for capacitors, SMD, and then we have a 0603 hand solar here. I think that's perfect. And for the 100 nano, I would like a 0402 hand solar. And the LED, I would like an 0603 LED. So let's see if we can find an LED. LED SMD and 0603 hand solar And the mounting holes, normally I use 3.2 millimeter mounting holes, and there's a lot of different ones to choose from here. Let's just take one with a pad like that. Then we have the right angle connectors, the QWIIC connectors, and we could just see over here in the specifications. So we have to look for this SMB04. And let's see if we can find that one. So we have one here. This looks correct. And I can just show you, if you're not able to find the footprint, there's a lot of very nice sources around where you can find the footprints, also 3D models and so on. Just need to click OK to this one. I can just show you. There's this page here called SnapEDA, and in here you can see the symbol and the footprint, and you can see the 3D model or step files. You can download the 3D model, and you can also download the symbols and the footprint in the format that you need. You just press here and then you will get a list, and of course right now we are using KiCad. So check it out here in SnapEDA or SnapEDA if you need some special footprints or something that are not defined yet. You can always try and see if you're lucky in here. I'll also put a link down in the video description for this one. Let's get back to the schematic design here. So we need a pin header. And this is just a 2.54 millimeter pin header standard, 1x10. And it's this one, the vertical, and we have the 2x3. So we need to go down here, 2x3 vertical. Then we have the resistors. We can just use some 04, 02 resistors. So resistors, SMD. Yeah, sometimes there's a small hiccup here. Of course I can select all the other ones that, except the one that I need. And there we have it. 04, 02 and solar. And we need the same down here for the 1K. We can just copy. And the solar jumpers. We have a jumper. There's a lot of things to choose from here. I think this is nice, this one. So that was the wrong one. That was for the next. We need it down there for the 2 pin, for the 3 pin. Open. this is the one. That one looked perfect. And we have this for the 2-pin solar jumper, and we have already defined the footprint for the IO expander here. And of course it's also possible to put in, you know, all the details about, you know, part numbers from, let's say that you buy your stuff from Mouser, then you can insert a line over here called Mouser, for example. I think we can just, let's say, new field name, let's say Mouser, and then you can insert the part number, the Mouser part number here. We can just try and check that out. Mouser. And then let's find it, TCAL9539PWR. And I live in Denmark, doesn't matter right now. And here you have the Mouser part number, so we can just copy that one. And we can insert it into the schematic here, like that. And then if you need to order parts, if you have already inserted all these part numbers, then it makes the process of ordering the parts and getting a bill of materials, it's very easy, and calculate prices. If you have, let's say you need to produce like 100 pieces, then you can just upload this bill of material to Mouser, and then you will get a price out. So maybe that's, yeah, some ideas for another video at another point. But I think this is good for now. Let's check this and say okay. Now we have all things that are needed for making the PCB layout. We have a complete design. We have defined all the footprints, and we have all the designators in place. So I think it's time to start up the PCB layout. We can just save this, file, save, and we can switch to the PCB editor. And we can try and import all the parts here. So we can just say update the PCB from schematic. And it does a lot of work, imports all the footprints, update PCB. And there were no errors, there were some warnings. That was for some of the mounting holes, or there are some unused pins on the quick connectors, and this is just warnings, and this is fine. We'll just say close, and there we go. We have all the parts, and now we just need to place the parts where we approximately want them, and then make the PCB. Let's get started making a rough placement of where we need the parts. So we would need the pin headers to be on each side of the board, approximately like this. Then we need a quick connector in one end and a quick connector in the other one. So like that. And then we, of course, we need mounting holes in each corner. Like that. And then we need the port expander to be in the middle. Something like that. And what else do we need? We need the resistors here to be placed over here. I would like this pin header to maybe be behind this one. Then we need, there was an LED somewhere, it's right here. Could place that one close to the input connector together with the 1K resistor. Like that. And you can see right now we are just moving along on a 1mm grid. And the solder jumpers I would like to have them on the back side. So we can just flip them over. So just select the part and then press F for flip and flip. So we can just move them out of the picture for now. And we need the bypass or decoupling capacitors to be close to the power pin. That was pin 24, so it's up around here somewhere. Maybe like that. Something like that. Yeah, that's basically it. Maybe we could move things a bit closer. Roughly like that. So I can see that there's an issue here. You see all the lines there, they're simply crossed. So maybe it would be a good idea to place pin or signal P17 here on pin 2 instead. But luckily this is no problem. I can just save what we have right now, then go back to the schematic. Sorry, this was the part design. So we are just back here. And let's have a look here on this. So we actually want P17 to be up here on pin 2 instead. So we can try and move all this and then say, can we do that mirror vertically? Yeah. Like that. Then press save. Go back to this PCB layout. And then say tools, update PCB from schematic. Update PCB. Voila. That was easy. It makes the PCB layout much more simpler. And I think that this should be possible to do in a, yeah, that should be just a 2-layer PCB, this one. So the next thing is to maybe make the edge cuts, so the outline of the PCB. So we select it over here, and we can place an, yeah, maybe this could be like a 30 times 45 millimeter PCB or something. Let's try and place a rectangle. So this is, we can see the size here, so 30, and then we can just drag this, and we see the width down there, so that's 45. If we are lucky, this should be possible to pan out Yeah. Let's select this square again. And then we can see shape modification. We would like to have some rounded corners. We could just try and make that 5 millimeter as a beginning. Let's try and move our mounting holes a bit. And we can see here we are on the grid. So if we move up here, it's not so pretty with 5 millimeters. Let's see how far are we here. 1, 2, 3, 4 millimeters. Yeah, it should be a bit less. So if we select all this, we can try and select all the lines again. Or we could just do another thing. We could just say Control Z and then highlight it again and then say shape modification. And we could say 3 millimeters. Let's try that. And then move this to the corner. Yeah, I'm not really happy about that. So that should be shape modification, maybe 4 millimeters. Like that. I think that's acceptable. Then of course I have a problem here because I made this Control Z and I forgot to change the size, so I can just delete this one more time. I think that's easier. And then say place rectangle. And this is 30. And I want to move that out in 45, like that. And like that, and then we say shape modification, fill the lines, and we would like the radius to be 4 millimeters, like that. And let's move that up a bit there, and J1 here, approximately. Take all this stuff. Go up here, and the output quick connector there. Let's move the mounting hole here, like that. And the other mounting hole, and the last one here. Then there's a bit of symmetry in it. And we would like this one to be in the middle as well. So I think it's around here. Let's center it there. And we need this one to be centered as well. That's around there. And we can of course make our own 0. And we can say grid origin, and we can just make it right here. And then you can see if we place the mouse here and press space, then you can see that we have down here we have 0.0 down here. And then we would like to have the chip here, the TCAL9539 in the middle. So that would then make it 21.5 or 22.5, that's approximately there, and 15, it's approximately there. And then let's move this one a bit further back, like that. Let's take the whole part here. Like that. And then the other pin connector, approximately here. So I think it would be nice to have this on a 100 mil grid, and then we can just change the grid size. Then I will make a new 0 in here, so we have that as a center. And then you see down the bottom that we have 0.0 here in the middle. And then if we then change the grid size like that, then we can try and put these pin headers on a 100 mil grid. Something like that. Yeah. And this one, I think that's fine. Like that. Could just check that they are the same level. They are. And then just for fun, let's try and place a pin connector across just to check it. So we need a pin header and maybe like a 15 pin. It's just to verify that the holes are across each other. So I've placed this one there, and then we should be able to have the other one. Something wrong here. Mil grid. That was strange. I need of course also to change the grid size here. So I need that to be a 100 mil grid. Like that. And let's go down and check it out here. Like that. And let's see if we move the mouse. We need to move this down a bit. Like that. So now we have it on a 100 mil grid. And we can remove that one again. And I just need to have those with the same distance to the edge, these connectors here. I'll just move back again to a millimeter grid and then change this to like a 0.100 or 0.1 millimeter accuracy. So let's take those two and then just move them so they have the same distance to the edge, like that. Just take 1, 2, 3, 4, 5, 6, and down here 1, 2, 3, 4, 5, 6. So I need to move them up 1 bit. Like that. I think that's fine. And we can then move this a bit further in. Then we have a bit more room for the pin header here. We have plenty of space on this design. Let's take it and move it a bit further back. Like that. And then we can just have like a view on how it looks on the 3D viewer. Something like that. And you can see that we need the 3D model for the QWIIC connectors. But I think this looks okay. So let's close this for now. And we can also, we don't want to see all these texts here. This is in the fabrication layer, I think. So we can turn those informations off. They are not needed right now. All right. Let's start routing some of the pins here. Then we can get a better overview of what to move around. So let's start and take all the signals to the pin headers. So we say place or route, sorry, just go down here on the part and just hit X and then go down here. Maybe we should move it a bit further back. That. Let's see, like that. The first one was the ground pin, so and like that. Like that. And X. So this is quite easy to route this. That was all 8 of those. Then we can take the other ones here. And this starts here, X. Just move the decoupling capacitors a bit. Like that. And of course we need the decoupling capacitors to be as close as possible to the power pin here. I think this is fine. And the 10 micro could be there. And what else do we have that are easy? We could take the diode here and place it up here with the input connector. Something like that. Move the resistor like that. Label on top here like that. And a wire like that. And of course we will put a copper pour on the top and bottom side and connect the ground pins there. So what we basically need to route is all the signal pins and then the VCC pins. Let's see what we can do here. We have the reset pin coming in here. We have SDA. It's on the top side, and we have A0 and A1. And we have the interrupt there, and the SCL line up there. So we could try and route SDA down here. Maybe move those up a bit. Out here. Just say SDA. Like that, and SCL. And then we have 3.3 volts, so we need to put power up here. And we need to get it over here and down to the chip. And we need to get it to the connector. Could do something like that. And we need to give it down here to the LED. So we can just say like that. Something like that. And then of course we have 3.3 volts down here as well. So we can just go to the bottom layer and just change to the bottom layer. And then go up here. We could place a via. Then we are on the top side. Alright, let's try and route the SDA and SCL lines. So we can take the SCL line, place it via, maybe just down here. Up here. And then put a wire. Let's try to get into the SCL line like that. And the Control Shift V, and then the SDA line. And let's see, we need to go underneath. So now we have the signals so far, and we can just route them to the output connector here. So we can change the layer again to top layer. and SCL is up there, like that. So just a small kink there, like that. And SDA. Like that. And then we have 3.3 volts. We need to bring that from the top up here. We can just say put a veer right there, or move the veer down here, I think. And then go to the bottom layer. And here we have the power. V for veer, like that. And the ground one will be added later. And we also have a ground pad there. So then we have A1 and A0. We should try to get them routed. So we can try and go on the back side with this one. Yeah. And then route it up here to A1. And then we have the interrupt pin. And we need to go on the outside as well here. Via. Like that. Then we only need A0. See, it would be easier to go inside. Like that. And then we can just route it to the pin out here. Like that. So far so good. Then we have the resistors, and then we can try and place them as smart as possible. Let's try and put them here. Move. And I think I don't want to have the designators on the silk screen in this design. So I can just select them. I think it's fine to have them on the connectors. And on the U1 that's fine, J5 that's fine. Like that. And then we can move those like that. And J2, move, and rotate, R for rotate, like that. Let's see, at J3, J4, fine, J5, perfect. Let's see with these resistors where they make sense. We have the reset line down here. Yeah, that could be around here then. A0 is up here. And we could just move this away a bit. Like that. Just try and delete that one. I want to go up. Yeah, maybe like that. A0 is up here. That. Reset there. SDA line. It's coming through here. And we have a SCL line also close by here. Like that. Interrupt, pull up resistor down here. A1. There. Reset there. And interrupts. So then they are nicely together. Just move that a bit. Like that. And then I think it's time to connect these resistors. Let's see. Interrupt pin. That was easy. A1. Could try and go in here. D for drag. The reset pin. Can just make a via here. And then shift the layer. And then go in here. And a via there. And then the SCL line. We can just try and like that. Like that. And we can do the same for the SDA line. Just connect it there. Disconnect there. Something like that. All right. What signals do we have left? We have A0. So we can just say go forward and then via. Then we're on the other side and connect it to A0 there. Something like that. So this is ground, 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 and then we need to place these solar jumpers, and yeah, we could try and put them here in the front. So we have the pull-up resistors for the SDA and SCL lines. So something like that. Then I could move the power here. Like that. Like that. Then we have room for the solar jumper on the other side. Something like that. And then it's easy to connect to 3.3 volts. And we can put a via here. Sorry. Like that, and then X, V. Like that. X, V. Like that. And then we have the pull-up resistors in order. And then we have the address select pins here. So we could put one here. And the other one below. Like that. And A1 we have over here. I think we'll just put a via over here. Like that. And A0. It's up there. So I think it would be smarter to change A1 and A0 here. Something like that. Drag it a bit down. Then we can try and route it up here and catch A0 there. I think we have all the signals routed now. We can just remove that text like that. Yeah, we have some pull-up resistors here that needs to be connected to the 3.3 volt net. And we can maybe catch it down here. Like that. And this is also 3.3 volt. So we can just go in. So if we do it like this, we just route through. Like that. Drag this down there. And I want the 3.3 volt net to be a bit thicker. So we can just say mark one track and then press let's see how to select U and control U, and do we have more? So we could try with 0.3 millimeters. And it's the same size as the pad here. And we can just try to select this U. There we have another track. Like that. And then we have 3.3 volts down there. We have the track down here. Then we can say properties to this. 0.3 millimeters. Okay. So basically we have all the tracks routed now that are needed for the signals, and the remaining one is just a ground. And we can just say, let's place some VS close to all the ground pads. The through-hole ones, they are connected already. That. That. Like that. And then the last one here, the LED. Like that. Let's try and have a look on the 3D design, how it looks. We need, what else do we need now? We need to find the 3D model for the quick connectors. I think we should put some labels here on the pins on the PCB so we can see what is what, and also put some text and stuff here on the backside as well. Okay, let's try and find the 3D models for the quick connectors. So we just double click here on the part, and then there's one called 3D models here. And I have the 3D model already in a library. This is this one. and we can see that it doesn't exactly fit, so we need to put it in place. So rotate it in -90 at the X direction, and it's a bit above, so we need to move it down in the Z direction. That was a bit too much. -0.3. Yeah. And what in the Y direction? .25. Yeah, I think that's fine. Okay, let's try and remember 1.25 and -0.3. So I need to do that on this part as well. Add a 3D model. And X -90. And set this was 1.25, right? Yeah. And -0.3. Yeah. And then let's have a quick look on the 3D view. Like that. Now we have all the parts mounted. We can see them in the model. And of course over here you can enable and disable the parts. This is the through-hole parts and this is the SMD parts. Okay, let's close this. And let's see if we can put some labels on. And we also need some dimensions here so we can see the size of the PCB. But let's try and put some labels on here. Draw texts. So we have one called 303. And that should be on the front silk screen layer. And maybe this should be 1, maybe 0.2. Let's see if it gets too big. Sorry, that's a mistake here. Like that. And for some reason it's rotated. Just flip it then. And that's 303. And we have from P0 and upwards. And then we could try place add text again. And then P10. And 1, 1 and 0.2. It's really strange why it, maybe I should say that I'm on top layer. place texts P10 like that. And then this should be front silk screen. Place texts P11. Okay. And if I maybe it's easier to just duplicate these ones like that. And this is then P11. $12. 13. 14. 15. 16. 17. And we need a ground like that. Then we can try and rotate everything here. And now of course I need this to be in the opposite end. And the distance we can align that quite easily. Now we just need to have the order in place. So we just say, okay, ground, this is approximately there, and 3.3 volts is approximately there. Then we can select all the texts and then say align, and then we can align them so they are centered, and we can align them so that they are with even spacing like that. And then we can duplicate that, just move them down here. Then we of course need to rename them. That's P0. P1. P2. P3. P4. P5, P6, P7, and then we could also align those to be centered like that, and then we can move them into place. So it just touches the magenta color there. And let's do the same for this one up here. Something like that. And we should also put some labels here on the small header here. So maybe we can just take some of the text here. that. A1. A0. There should be resets. Let's try tilde, curly brackets, curly bracket end. And that's of course not the end pin, should be the reset pin. And then we have SDA. Then we have Sccl. And then here we have the int. Tilde, curly bracket start, and curly bracket end. And we could also align those so they are centered. Move them like that. Yeah, it's not so far away, I think. And move these. Are they centered? Yeah. Like that. I think I would like the text to be a bit thinner. Just select them all. Properties. Maybe I chose something that are not. Let's see if we can take it. Oh, we apparently have to go in and do it one by one. Okay, let's keep those then. We can just have a look here in the 3D viewer how it looks. Yeah, I think that's okay. We just enable the references as well. Alright, then we need some stuff on the backside as well. Should just move the solar jumper text a bit. Let's try and do that. And then we could flip the whole board. And flip board view. So now we are on the other side, and we could take those texts here, move them over here. Like that. And I think that's fine with Solar Jumper 1. And let's put some text on the backside. We could just put a name here. Add text. Let's call it the mbob. and TCAL9539PWR, and we would like that to be 2, 2, and 0.3 millimeters. And that should not be that layer, that should of course be the bottom silk screen. Oh. And I need to go to this layer. And it should be on the bottom silk, like that. And then it could also be nice to have a small text box with, you know, the informations about, you know, the A1 and A0 signals or the addresses. So we could maybe make a small box, but let's try and make some text first. So we would like to have something called I2C address, and that should also be on the bottom silk, and maybe 1 and 0.2. Yeah, something like this. And then we had 00, that was address 74, and 01 was 75, 10 was 76, and 11 was 77. Something like that. Can we draw some lines around this? We need it to be on the right layer. Alright, rectangle. And it should be 0.2 millimeters in width. And place a line. And that should also be 0.2 millimeters in thickness. Something like that. And we could place it close to the solder wire jumpers over here. Something like that. And we could place like a KiCad logo, I think. Add footprint. There was maybe one called logo. Or what was it? Our symbols. KiCad logo. Try this one. Let's try and rotate this. Should have it, oh sorry, we need to have it on the right layer. Flip. We could move it in here. Something like that. And we could place some more texts. So we could say powered by and we could say YouTube made by Morten, and the channel sponsor name we could also put that on. That is PCBWay.com, and I would like that to be 1.5, 1.5 and 0.2. Let's try and see how that looks. Awesome. See if we can find some place for this. Yeah, it should maybe be a bit smaller. That. Maybe we could take this and move a bit. Move that up a bit. And take this text. Yeah, we don't want to go over the solder jumpers down there. Like that. Alright, we could just have a look on how that looks like. Could move that up a bit and make it a bit smaller, I think. Then say 1.5. Like that. And we could take this as well. Just move it up a notch. Like that. And now we just need to put a few more wires, and we need to make a flood fill here on the top and bottom layer. So we just go to place and add fillet zone, and we can just go into a 1 millimeter grid, and then we say we need to be on the top layer, place, fillet zone, and we need to put something on the bottom layer and the top layer, and we need it to be ground, and we need the clearance to be 0.2 millimeters, minimum width 0.2. The gap here with thermal relief could be 0.3, and spoke width should also be like 0.3 millimeters. And then we can just place the area. Like that. And then B. And we fill everything. And let's see if we have some areas we could just try and put some vias in there to fill them in. That looks a bit better. And then we can move away from that 1 millimeter grid. And then we press B for updating again. Then we see this area that's then filled as well. Do we have more? Yeah, we have something here. And let's try and see how that looks better. And we can put it here there. And we can just fill some vias in different places here to tie everything together. Just Control D. And then I try not to put something, on the text. Then the silk screen could be a bit nicer. Let's see out here. There. Some here close to the capacitors. There's no room there. It's fine. I think that's close to be it. Let's try to update this. That's a bit in here, but it's impossible to fill out. Maybe we should move that away a bit. Yeah, you see here there's a distance of 0.3 millimeters to the edge. You can also adjust that if you want it closer, but I think that's pretty nice to have that a bit further back. Let's have a look on the 3D model now. Okay, and let's have a look here on the back side. Think that's acceptable. We could just try and make a verification if we have some issues. A design rule check. That's very important before you submit a design. Please remember to do a design rule check. And that could be like a trace or something you forgot, or something that is a bit too close together, then you'll get a warning here. And let's see, we have a few warnings here that we need to take care of. There are some board edge violations. It doesn't matter, this is the pads here on the connectors, but we have something here. Let's try and look at what it is. Need to take it again. Inspect, design rule check. There's something down here. There's this veer, so you can see this is too close here. So I can just move it down like that. Then we should be clear of that interrupt pin. Let's try and verify that. Design rule check. And then we only see the 4 errors that are here. This is these pads, they are too close to the edge, but that's fine. And let's just have a look on the design one more time. So this is the final design, ready to be shipped off to the manufacturer. And I can just briefly show that, how that's done. Let's save the design. And then we can go to tools, and then I have an external plugin. And then you can actually just go to PCBWay and have that, you know, this will just package the whole design and submit the data to PCBWay, and it will automatically, you know, calculate the price for the specifications that you insert into the different fields here. But it detected the 2-layer board that we did, 30 by 45 millimeters. 2 layers, and you can change the colors and you know, the surface plating and everything, and then you get the prices over here directly, and then you can just save it to the basket and place some orders. Thank you for watching. See you in the next one. Bye.